AC ripple. When a power supply is working properly, it produces a pure DC signal. As a power supply ages, its ability to produce pure DC falters because of contamination, wearing out, the capacitors get old, that kind of thing. They get warped. So they're not working optimally. Power supplies use electrolytic capacitors, which we were just talking about, to filter or smooth voltage after conversion. When an electrolytic capacitor fails, it allows more AC voltage through. This is called noise or ripple. So the capacitor acts as a filter across the positive and negative of the DC voltage, pulling out all the stuff that shouldn't be in there. And what happens is it stops pulling it out because it's not working as well, so it just allows the current through. So it's not filtering anymore, and that's the problem. Testing for AC ripple. Set a multimeter to read AC. Connect a 1 microfarad capacitor to the red lead. With the power turned on, measure the DC voltage. Any ripple present is displayed as AC voltage. So if you can read AC across a pair of DC circuit terminals, then you have some ripple going on and you have a bad filter, electrical filter. So what you need to do is just change the power supply. Don't try to repair it. It's not worth it. So testing for resistance. We talked about this earlier, that resistance is measured in ohms, is the opposite to the flow of current through a conductor. Now, if you go on to take an electrical engineering class, a lot of this stuff you're going to see is not true. Electricity actually flows in the opposite direction. The whole flow is in the opposite direction. So there are some caveats to these rules, okay, but that's way beyond the scope of this class. So just take it for granted that all of this is correct, and the red is red, you know, positives, that kind of thing. The flow is in the right direction. We're not talking about whole flow here. If anyone just graduated from engineering school, we're not talking about the electron hole flow. So resistance is measured in ohms, is the opposition to the flow of current through a conductor. So resistance tries to slow down the current. I don't want to let you through. I'm only going to let you through at this rate. And then I'm going to get hot doing it because I'm doing a lot of work, right? And then eventually, if you give me too much to do, I'm going to blow up. I'm going to fail. So that's what happens if you melt the resistor. They'll just pop. And then you want to place 1 lead of the meter on each side of the circuit to measure resistance. Measuring the component soldered in its circuit can yield inaccurate readings. So if you're testing a component on a board with a multimeter, that's no good. You can't do that. You need a special type of instrument, excuse me, called a multifunction meter to do that, or an oscilloscope. And those are a lot more expensive, like $1,500, and you really have to know how to use them. So to test the resistance with the power off, do not connect the meter to an electrical outlet. So you really want to measure it while it's off, or pull the component out if you can. But again, we don't do board level component work. That is not something you should be getting into at this stage. If the meter is set too high or the resistance is too high, the reading is inaccurate. Before you take a reading, ensure that any charge stored in the capacitor is properly discharged. How do you discharge a capacitor? So somebody comes running at you to attack you with a capacitor, a big one, and you're like, oh man, that's enough to blow me in two. But you see 2 metal wires coming out of the capacitor, right? Out of the bottom. That's what goes into the circuit board, and you got the can at the top. And we told you if they're bulged at the top, they're bad. If they're bulged on the side, they're bad. If they're bulged on the bottom, they're bad. So how do you know if they're discharged or charged? So you come across one out in the wild, and it's just on the road looking at you saying, come get me. So you run over there with a screwdriver, and to discharge it, you short the terminals with the screwdriver. Do not do it with metal in your hand while you're standing on the ground in water. Don't do it. So what you want to do basically is just short those 2 terminals, and it'll flow from one post to the other. It won't flow through you, but it will go from one to the other, and it will make a loud crack sound. So that's how you discharge them and render them safe. So if you have 2 terminals on a capacitor, you short them out to discharge them, and that's what they mean here. Before you take a reading, ensure that any charge stored in a capacitor is properly discharged, and the way you do it is you just short the terminals. You don't take your fingers and touch them. That will hurt. You want to take a screwdriver, something metal, not not a paper clip in your bare metal hand, but something with a little bit of insulation, and just short the terminals out, and that'll discharge it.